A recent report stated based on a sample of 250 truck drivers, there is a evidence to indicate that on average, independent truck drivers earn more than company hired truck drivers. Does this statement describe descriptive or inferential statistics? So, what do we know here is that we have a sample size of 250 truck drivers, and based on that sample, we have an evidence to indicate that on average, independent truck drivers earn more than company hired truck drivers. So we have to describe whether this is a descriptive or inferential statistics. Descriptive statistics, it describes, it helps us in finding the pattern in a data set or collect the information from the given data set. That's the descriptive statistics. Inferential statistics, this this inferential statistics use a sample to make a generalization or a estimation or like a prediction for the population. Okay, so here, since they use the sample of 250 truck drivers to find the average earning of a truck drivers, so this is our inferential statistics. In number two, parking at a large university has become a very big problem. University administrators are interested in determining the average parking time. Average parking time, that is the time it takes a student to find a parking spot of its students. An administrator inconspicuously followed 250 students and carefully recorded their parking times. What type of variable is the administration interested in collecting? So here they are interested in determining the average parking time, right? And that average parking time is the time it takes a student to find a parking spot. So that is the of determining the average parking time is our variable. Now, what type of variable is this? Is this quantitative or qualitative? Now, average parking time, it occurs in number. Naturally, it is our quantitative data set. Okay, so the administration interested in collecting quantitative data. The amount of television viewed by today's youth is of primary concern to parents against watching television. 330 parents of elementary school age children were asked to estimate the number of hours per week that their child watches television. Okay, now here we have 330 parents, okay, and they were asked to estimate the number of hours per week that their child watches the television. Now we have to identify the data, how the data is collected in this study. Now we have the four option. Is it from published source? Are those 330 parents collecting the number of hours that their child watches television from some published source? No, right? From a designed experiment? No, they are not controlling. The parents do not control this experiment, do not control the time that the child watches television, so this is not an option. Let's go with number C, from a survey. So we do not have any survey, so children are not asked whether asked about their number of hours, so it's not a survey. Now the last option we have observational, so it means here 330 parents, they do an observation, they observe their child watching television and note down how many hours they watch per week. Okay, so this is our the observation. So the data collected is observationally. Next, parking at a university has become a problem. So it's the very same experiment that we had in number two. Administrator are interested in determining the average time it takes to a student to find a parking spot. They followed 110 students and recorded how long it took each of them to find a parking spot. Now the next we have to identify the population of interest to the university. Now, so population of interest, it can be a person, thing, or event, okay, in which we are interested in collecting data. So the university administrators, they are interested in collecting data about data of a student, right? So our student is a population of a interest. So students are the population of that university. Identify the variable of interest to the university administrator. Since they are interested in determining the average time it takes to a student to find a parking spot, so average time or time it take a student to find a parking spot. So this is our the variable. So this is our number B. Identify the sample of interest. So their sample is 110. So 110 is the sample. 110 students. Next, in an eye color, 25 out of 50 people in a sample had a brown eyes. So we have a total sample size 50 people, and out of 50, 25 had a brown eyes. In this situation, what does the number 0.5 represent? Now, we have like four options here. So is it a relative frequency? So relative frequency is the number of people divided by a total people. So how many people had a brown eyes? 25, right? So 25 had a brown eyes out of 50. So the fraction, so what fraction had the brown eyes? Let's find out. So 25 divided by 50, 0.5. So that 0.5 is the relative frequency. Okay, now the class frequency in this case would be 25. Okay, class frequency is the number of students in that brown eye category. Class is a brown eye. Class percentage is so you find the percentage. So what percentage of the people had a brown eyes? Since 25 out of 50 had a brown eyes, so 50% would be the class percentage. So 0.5 is the class relative frequency. In 2023, ENMU had a 600 freshmen. Okay, so we have 600 freshmen. So that is the number of freshmen is the frequency. So 600 freshmen, 560 sophomores. So number of sophomore is a frequency. 440 juniors, 440 juniors, and 400 seniors. Okay, so frequency is the number of data in each category or in each class. Now, next we are asked to find the relative frequency, and relative frequency is the frequency divided by the total number. Now, what is the total number of ENMU? So let's find the total here. So the total number of students in 2023 is 600 plus 560 plus 440 plus 400. So 2000 is the total number of students in 2023. So to find the relative frequency, you divide the frequency by total. Okay, so 600 divided by 2000. So that is 0.3. To find the relative frequency for sophomore, 560 divided by 2000, 0.28. To find the relative frequency for junior, 440 divided by 2000, that is 0.22. And for senior, 400 divided by 2000, 0.2. And when you add all this relative frequency, the sum has to be 1. Okay, you can check this: 0.3 plus 0.28 plus 0.22 plus 0.2. The sum has to be 1, and that's what we have. Now, to find the class percentage, you multiply each relative frequency by 100% and you get the percentage. 0.3 times 100, that is 30%. 0.28 times 100, that is 28%. 0.22 times 100, that is 22%. 0.2 times 100, that is 20%. And when you add all this class percentage, the sum has to be 100%. Next, the total points scored by a basketball team for each game during its last season have been summarized in the table. We have to construct a histogram. So we have a score here. So these are the score, and in each class we have the number of team. Again, the number of points is scored by the team. So this. Okay, so we have in the score 40 to 60 we have 3. So along the horizontal we have the score. So score is horizontal and the frequency is our vertical axis. Let me write F for the frequency. Now our score is starting from 40. So let's say this is 40, this is 60, this is 80, this is 100, and this is 120. Now the frequency give us the height of a bar. Okay, so you draw a bar of this height in each class here. So along the vertical axis, we have let's say this is 2, 4, 6, 8, 10, right, 12, 14, 16, 18, 20. Now in the class 40 to 60 we draw a bar of the height 3. So 3, this is 2, so 3 is somewhere here. So you draw a bar of the height 3. Okay, so this is our bar for the score 40 to 60. For 60 to 80 the height of a bar would be 8. So 8, so this is 10, this is 8. So you draw a bar, make sure these two bars are connected to each other. Okay, that's the histogram. If you draw bars separately, then it's your bar diagram. You are asked to draw a histogram. So this is the bar for 60 to 80. So 80 to 100 we have 12. So let's draw a bar of a height of 12. So this is 12 here. And finally we have 7 for 100 to 127. 2, 4, 6, 7 is here. Okay, somewhere here. Okay, and it would be best if you could color each height with a different color. So let's color yellow for this class. Let's have a green for this second. Let's have this color for our next interval, and finally this color for our last interval. Okay, so this is our histogram. Make sure your bars are connected to each other when you are asked to construct a histogram. Okay, the next here we have The scores for statistics tests are given, so we have to create a stem and leaf display. So every score are a 2 digit. So this stem and leaf, it has a stem and it has a leaf. So stem, you have to find this stem at first, and this stem you can take the digit in the tens place as a stem. Okay, so let's collect our digits at a tens place as our stem. Okay, so let's write down the stem, and make sure you are writing this stem in the ascending or descending order. You can start from small to big or from big to small. So the smallest number here we have like 18, and we have 1 in a tens place. So 1 is the first stem. The next we have okay, 20. So we don't have number with a 2, 3, 4. So we have let's say 53. Next small, so 5. Similarly we have number starting with 6. So we have a number in the 70 line, we have number in the 80 line, and we have number in the 90 line. So this is our stem. Okay, now we write down the digit in the ones place, okay, next to this stem. So let's start with 18. So here the smallest is 18. So 1 is our stem. Now 8 is the leaf. So you just write down 8 next to this vertical line. So we have 8. Now do we have any score in the line of 1? So like from 11, from 10 to 19. So we don't have. Now let's go to the number 50s. So we have here, okay, so we have 53. Just let me highlight first. Let's say what we have, 50. Okay, so for both of these score we have 5 as a stem. Now you write down the digit at one's place as your leaf. So you start with a small number. So we have 0 as a small number, and the 3, the second is small. So we are done with the number starting with 5. Now let's go with the number starting with 6. So let's highlight first. Okay, so here we have 66, 69. Yeah, that's all. So start with the small, so 6, then 9. Now let's look for the number starting with 7. 76, 77, 79. Now you write down, collect every digit at one's place starting with a small. So we have 6, 7, 9. So 6, 7, 9. Now let's go with the 80s. So we have 87, 88, 89, 83, 88, 82. So the smallest number in one's place is 2. So we have 3. We have, oh, we do have 85. So we should not forget this 85. So we have 85. So that's 5. Then the next we have 87. So 7. Then we have 88. We have 288, right? So you need to write 8 twice, and we have 89. So 9. So these are the leaf for stem 8. And next we look for the numbers starting with like 90s number. So 91, 94, 96, 97, 99. That's it. The smallest number at one's place is 1. then we have 4, then we have 6, then we have 7, then we have 9. Okay, and this is our steam and leaf display. So based on the given data, you have to pick your steam. Okay, so here we have a 2-digit number. So the number or the digit at tens place are the steam, and the number at the ones or the digit at the ones place are our leaf. Okay, next here we have a dot plot of the speed of a sample of 50 cars. So this is a dot plot passing a policeman with a radar gun is shown below. What portion of the motorist? So we have to find the portion. Okay, we have to find the fraction. What fraction of the motorists were driving above the posted speed limit of 55 miles? Now, on the horizontal, we have the speed, okay, in a miles per hour. So this is the speed, and each dot indicates the car driving that is speed. Okay, like here, let me take one dot. So here we have this dot, so it means this there is a one car that's driving with a speed 46. Okay, like if we take this, then we have 1 2 3 4 5 6 7 car driving with a speed 55. Okay, so that's what it means here. And what we are asked to find the fraction of the motorist that they were driving speed limit above 55 miles per hour. So above 55 means we are looking for the car driving at the speed greater than 55, means everything on the right of 55. So let's count. Okay, so we have one car, 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. Okay, so we have 25 car. So out of 50, 25 cars are driving above speed limit 55 miles per hour. Now what is the fraction? So out of 50, 25 are driving above posted speed limit. It means, so the proportion is 25 divided by 50, which is 0.5. So 0.5 is the proportion of the motorists driving above the posted speed limit. Next, in number 10, a standardized test has a mean score. So we have a mean score 500 with a standard deviation 100 points. 5 students score are shown below. So we have these scores for these 5 different students. The question is, which of the students have a score within 2 standard deviation? Now let's find the 2 standard deviation. So we have a mean. So this is our x bar. This is our standard deviation, and we are asked to find 2 standard deviation. Okay, so 2 standard deviation is x bar plus minus 2 times s, or this is x bar minus 2s to x bar plus 2s. Now you replace x bar and s with the given, so our x bar is 500 minus 2 times standard deviation is 100. So here 500 plus 2 times 100. So this is 500 minus 200 to 500 plus 200. So the interval here, 2 standard deviation of the mean interval is from 300 to 700. So every student whose score is in between 300 to 700 are within 2 standard deviation. Now we know here, let's check each student's score. So Adam has a score 575. So this is within this interval. So Adam is the one. Beth has a score 690. 690 is also in this interval. So Beth is also the answer Carlos has a score 750. 750 is not in this interval, so Carlos is not within 2 standard deviation. Though has a score 280. 280 is not in this interval, so this student is not in the interval. Ella has 440, so 440 is within this interval, so Ella is also within 2 standard deviation. So our answer is Adam, Beth, Ella. So Adam, Beth, Ella. So D is the answer. Okay, so if you are asked one standard within 1 standard deviation, then 1 standard deviation means x bar plus minus s, and this is x bar minus s to x bar plus s. 3 standard deviation means x bar plus minus 3 times s, and this is x bar plus, first small number. Okay, so x bar minus 3s to x bar plus 3s. So this is how you can find the interval. The next, the data show the total number of medals, gold, silver, bronze, owned by each country winning at least one gold medal in the Winter Olympics. Find the measure of central tendency. We have to find mean, median, and mode. Okay, and we have to tell what does this mean, median, mode mean here. Now we all know how to find the mean. So to find the mean, so mean is x bar, so you add all this number and divide by the total number of data, which is, so let's add 1 plus 2 plus 3 plus 3 plus 6 plus 8 plus 9 plus 10 plus 12 divided by how many we have? 1 2 3 4 5 6 7 8 9. So if we add all these, so 12 plus 10, 22 plus 9, 31 plus 8, 30. Okay, hold on. 22, 31 plus 8, 39 plus 6, 45 plus 3, 48 plus 3, 48, 51 plus 2, 53 plus 1, 54. 54 divided by 9 equals to 6. So this is our mean. Now let's find the median. So to find the median, we must have our data set in the ascending or descending order, and we already have here. So 1 2 3 3 6 8 9 10 12, so already in the ascending order. Now we want to find the middle number. Okay, so let's take away each number from both sides. So one number from left, right, second number, third number, fourth number. So this is our middle number. So median m is 6. Next we are asked to find the mode. So mode is the measurement that repeats most frequently. Now which measurement, which data repeat most here? So here we have 3 repeating twice, so mode is 3. Now so if we look at the mean and the median of this measurement, they are same, right? It means that our data is symmetric data set. So mean means average value for this measurement is the mean. Median tells that 6 is the middle number, or 6 is the middle number of the given data set, and mode is 3 means 3 is the measurement that repeat most. Next we are asked to find the range. So our range is the largest measurement minus smallest measurement. Our largest measurement is 12 minus smallest measurement is 1, so 11 is the range. Now next we are asked to find the variance and standard deviation. Now to find the variance, You find the distance of each measurement from mean. Our mean is 6. So let's find how far is 1 from 6, how far is 2 from 6, how far is 3 from 6. Okay, so we find the distance of each measurement from mean. So 6 minus 1. So to find the distance, 6 minus 2, then 6 minus 3, 6 minus 3. So let's find the distance of this 6 from mean. 6 minus 6, then 8, 6 minus 8, 6 minus 9, 6 minus 10, 6 minus 12. So you find the distance of each measurement. Okay, so distance of each measurement from mean. Okay, so let's find the distance here. So this is 5, 6 minus 2, 4, 6 minus 3, 3, 6 minus 3, 3, 6 minus 6, 0, 6 minus 8, minus 2, 6 minus 9, minus 3, 6 minus 10, minus 4, 6 minus 12, minus 6. Then next, you square all these distance. Okay, so you are squaring, 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 squaring. You add, then you add. Okay, so let me find the square. 5 squared is 25, 4 squared is 16, 3 squared is 9, 3 squared is 9, 0 squared is 0, negative 2 squared is 4, negative 3 squared is 9, negative 4 squared is 16, negative 6 squared is 36. You add all these numbers and divide by n minus 1. Okay, n minus 1. So n is the total number of measurement. So how many measurement we have? Let me count. So we have 9, right? So you divide by 9 minus 1. 9 minus 1. And this is... So let's find this difference. So we will add all numerator first, then divide by 9 minus 1. Okay, let's go ahead and add all these numbers. +25 plus 16 plus 9 plus 9 plus 0 plus 4 plus 9 plus 16 plus 36. 124 divided by 9 minus 1, 8. Divided by 8, 15.5. So this is our variance, and standard deviation is the square root of variance. Square root of 15.5. That is 3.9. So 3.9 is the standard deviation. Okay, number 12. At the US Open Tennis Championship, a statistician keeps a track of every serve that a player hits during the tournament. The statistician reported that the mean serve speed, so mean serve speed is 100 miles per hour, and the standard deviation of the serve speed is 15 mile per hour. Assume that the statistician also gave us the information that the distribution of serve speed was mound shaped. Okay, so the distribution is mound shaped, which is normal shaped. symmetric. What percentage of the players serve between 115 mile per hour and 145 mile per hour? Okay, now since this is a mount shaped, let's start with drawing a bell shaped curve. So for number 12, let's start with a bell shaped curve. So this is our speed. So mean is 100. So mean is 100 at the center. So this is 100. Okay, since this is a mount shaped and symmetric, our 100 is in the middle and the standard deviation is 15. So x bar is 100, standard deviation is 15, and we are asked to find what percentage of the flares are between 115 and 145. Now let's find one standard deviation, two standard deviation, and three standard deviation. So one standard deviation is x bar minus s to x bar plus s. So you okay, that's one standard deviation. So you go 15 unit left and 15 unit right. So if you go 15 unit left, it's we get 85. 100 plus 15, 115. Now you go 15 on the left, 85 minus 15, that is 70. 115 plus 15, that is 130. The three standard deviation is you go left 15, right 15. 70 minus 15, that is 55, and 130 plus 15, 145. So one standard deviation is from 85 to 115. Two standard deviation is from 70 to 130, and three standard deviation is from 55 to 145. And the question here is, we want to know the percentage between 115 and 145. So 115 and 145. So we want to know the percentage from 115 to 145. It means we want to find what percentage of the measurement is in this interval from 115 to 145. We use, since it's a mount shaped, we use empirical rule, and according to empirical rule, what percentage of the measurement we find within one standard deviation. So our one standard deviation is, so this from 85 to 115. So this is our one standard deviation, and according to empirical rule, we can find, okay, what percentage of measurement do we find within one standard deviation? (68), right? So we have 68% of data set within one standard deviation. So we have two part here. So we have this part and we have this part. So these are symmetric, they are equal. Okay, so half of 68, that is 34. So we have 34% here, and we have 34% of measurement here. Like 34% of measurement from 85 to 100, and in between 100 and 115 we have 34%. Now according to same empirical rule, within two standard deviation, now what is two standard deviation here? So two standard deviation means the measurement from 70 to 130. So this is two standard deviation. Okay, so all this data set, so every measurement here are within 2 standard deviation, and within 2 standard deviation, according to empirical rule, we find 95% of the measurement. So from 70 to 130 we have 95% percentage. So it means, so our target is finding from 115 to 130. So we want to find the area of number of percentage in this region and in this region. Now from 70 to 130 we have 95%, right? From 85 to 115 we have 68. So the remaining is here and here. In the remaining, out of 95 is here and here. So remaining means 95 minus 68. So 95 minus 68, 27% of the measurement are here and here, and each has a half of this. So we have 13.5 here, 13.5 here. Now according to same empirical rule, within 3 standard deviations, so 3 standard deviation means from 55 to 145 we have 99.7 measurement. Okay, so we know from 70 to 130 we have 95%, and from 55 to 145 we have 99.7. so the remaining will be here and here. So 99.7 minus 95, so 4.7% of the measurement are here, and each part has a half of this. So that is 2.35% here, 2.35% here. Now I think we are almost there. We want to find the percentage from 115 to 145. So 115 is here, 145 is here. So from 115 to 145. So this is the region we are interested in. So here we have 13.5 plus 2.35. So in between 115 and 145 we have 13.5 plus 2.35%, which is 13.5 plus 2.35, that's 15.85. so we have 15.85% measurement within in between 115 and 145. Now let's go back to our option. So we have option 34, which is not correct, 13.5 not correct, 2.5 not correct, approximately 16%. So this is our final answer. Okay, next here we have number 13. In number 13, at the US Open Tennis, I think it will be the same experiment. Okay, they keep track of every serve. The mean serve is 101 miles per hour, so different mean. Standard deviation is 11 mile per hour. If nothing is known about the shape of distribution, now in this question there is no, they didn't mention about the shape of distribution. In number 12 we know that mound shape, the distribution was mound shaped and symmetric, and because of that we use our normal bell-shaped curve, we use the empirical rule. But number 13 we don't know what shape of the distribution, and you can't use the information given in number 12. Okay, you have to take number 13 as an independent question. So we don't know what shape of the distribution, and we are asked to give an interval where it will contain a speed of at least 8/9 of the player. So we want to find the interval which contain 8/9 of the player serves. And if now you will be given the former sheet where there will be a empirical rule, Chebyshev's rules. Now here, since we do not know the shape of distribution, we use the Chebyshev's rule, and according to Chebyshev's rule, we can find 8/9 of the measurement in the 3 standard deviation. So here basically you are asked to find 3 standard deviation. Okay, so let's go ahead and find 3 standard deviation. So finding 3 standard deviation means you are finding x bar plus minus 3s. Our x bar is 101, s is 11. Yes, now x bar plus minus 3s means x bar minus 3s to x bar plus 3s. So you replace your x bar by 101 minus 3 times 11, 101 plus 3 times 11. You simplify, you get the interval 101 minus 33, 101 plus 33. So 101 minus 33, that is 68 to 134. So the interval which consists 8/9 of the score is 68 to 134. 68 to 134, number B. Number 14, on a given day, the price of a gallon of milk had a mean price. So we had a mean price 2.03 with the standard deviation $0.07. A particular food store sold milk for around $1.96 per gallon. We have to interpret z-score. Now at first let's find the z-score. Z-score is given by x minus x bar divided by standard deviation. So x is the measurement or the price of a milk sold by that particular food store, which is 1.96 minus mean is 2.03 divided by standard deviation 0.07, and we get this is equals to -1. Okay, so our z score is -1. Now it means the milk price of the food store falls, okay, 1 standard deviation below the milk price of all food store. Now in numbers, so here, so it falls, so since it's a negative, it's below the milk price. Okay, and it negative means it falls 1 standard deviation below this the milk price of all food stores. So C is the option. Now A is not the option because it says it falls 7 standard deviation. No, our z score is 1, so it's not that true. In number B, it tells it falls 1 standard deviation, but it tells above the milk price. No, since it's negative, it's below the milk price. In number D, it falls 7 standard deviation, so this is not correct. So C is the option. Now number 15, we have here test taker scored 56th percentile on the verbal part and 34th percentile on the quantitative part. We have to interpret what does this mean. So now here, so 56th percentile, so some random test taker scored at the 56th percentile means 56% of the other test scorer has a score less than 56. Okay, it means he performed better than those 56% test takers, and the verbal and the quantitative part is at 34th percentile. It means 34% of the test taker has a score less than his score. It means he did better than those 34%. Okay, so it means, so the student performed better than 56% of the other test takers on the borrowed part and better than 34% on the quantitative part. So we have number 16, and here we are asked to draw a box plot. So to draw a box plot, we have to find interquartile range. We are given lower quartile, upper quartile is given, median is given. So at first, let's find the interquartile range. Interquartile range, and interquartile range is upper quartile. So Q U is upper quartile minus lower quartile. So 91 minus 71 equals to 20. So this is our inter quartile range, interquartile range. We need a lower fence, we need an upper fence. So let's find lower fence. So lower fence is lower quartile minus 1.5 times interquartile range. This formula will be given to you. So 71 minus 1.5 times 20, and we have 41. In the similar way, we find upper lower inner fence. Okay, so this is lower inner fence. Next we find upper inner fence, and upper inner fence is upper quartile plus 1.5 times interquartile range. This is 91 plus 1.5 times 20, which we get 121. And next we need lower outer fence, and lower outer fence is lower quartile minus 3 times interquartile range. So that is 71 minus 3 times 20, which is 11. Finally we need upper outer fence, and upper fence is upper quartile plus 3 times interquartile range. So here 91 plus 3 times 20, our 151 is the upper outer fence. Now once you have all these, we draw a box plot. So to draw a box plot, you can use a vertical axis or a horizontal axis. So let's use our horizontal axis for the data. Okay, now we draw a box. Okay, so at first we have to scale our horizontal axis. So let's start with a 10 here, and like 35, 10, 15, 20, 25, 30, 35, right? Then 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, right? 105, and so on to 155. Now let's see where is our lower quartile. So our lower quartile is 71. So we draw a bar or like a vertical line at 71. So 70 is here. So let's draw. So this is a vertical line at 71. We are drawing a box using lower quartile and upper quartile. Okay, so our upper quartile is 91. So this is 90, 91 is somewhere here. So this is our 91. So here we have a box. Okay, so this is our, so this line represents a lower quartile, and this line represents our upper quartile. Now let's draw a median of vertical line. Median, our median is 80, so 70, 75. Okay, so this is our 80, so vertical line here, so this is our median. Okay, now the next we have to draw whisker. Okay, and to draw that we have to know the lower inner fence, so we have to draw a fence here on the lower side and upper side. So our lower inner fence is 41. Okay, now let's take this 41 as the smallest and we find the next smallest measurement in our data set. Okay, so you take 41 as the smallest. Now what will be the second smallest measurement in our data set, which will be 59. So you draw a horizontal line, okay, from lower quartile to 59. So this is 50, so this is our 60, so 59 is somewhere here. So this is our 60. So this is our lower inner fence. In a similar way for the upper inner fence, our upper inner fence from calculation we have 121. Now you take 121 as the largest measurement and you look for the second largest measurement in the data set, which is 99. So you draw a fence up to 99. So this is 100. So 99 is somewhere here. So this is our inner fence. Now for the outer fence, so our lower outer fence is 11 and upper outer fence is 151. Now so 11 is somewhere here, and we can use, so 11 is somewhere here, so let's use a like open circle for our lower outer fence 151. So that's 55 somewhere here. So this represent our outer fence. Okay, now do we have any measurement which is not in our inner fence, upper lower inner fence and lower inner, so from lower inner fence to upper inner fence? So there is one measurement which is 39. So this 39 is not in between 60 to 99, so let's use a asterisk to represent 39. So this is 40. So we have this 39 outside the box here. Okay, and this is our box plot. In next we are in a box plot, which score if any would be outside the outer fence. So our outer fence is outside the outer fence, so this represent outer fence. So do we have any measurement here? It means do we have any measurement greater than 151? Do we have any measurement less than 11? No, right? So no. Which score if any would be outside the inner fence but inside the outer fence? So we are looking for outside the inner fence, means outside, inside the upper fence. So we have this 39 which is in between outer fence and inner fence. So this 39 is our possible outlier.